Hello everyone, in this section we have the dot product based on what we have here. Here we have theta, which is angle between these two vectors u and v. So the angle between u and v lies in this interval 0, pi. Here we have theorem for angle between two vectors. So angle theta between two non-zero vectors u, which is u1, u2, u3, and v, which is v1, v2, v3, is given by, so here we have theta equal to r cosine. In numerator on top we have u1 times v1 plus u2 times v2 plus u3 times v3, and divided by length of u times length of v. And here definition, the dot product u times v of vectors. So here again we have these two vectors u and v is the scalar u times v is equal to, so we're going to multiply u1 times v1 plus u2 times v2 plus u3 times v3, exactly same as what we had here in numerator. This means our theta is equal to r cosine u times v divided by length of u times length of v. Now here on this part we need to compute the following dot product. In part A we have the vector with components 1, -2, -1, dotted with the vector having components -6, 2, -3. So using the definition of dot product, so here we have 1 times -6 plus, and here we have -2 times +2 plus -1 times -3. So this is equal to, here we have 6 and plus -4 plus 3. So that is equal to -7. In part B, we want to take the dot product of vectors 1/2i plus 3j plus k and 4i minus j plus 2k, writing in component form. So here on this part we have 1/2 times 4 plus 3 times -1 plus 1 times 2, and this is equal to 1. Dot products and angles. The angle between two non-zero vectors u and v is theta equal to r cosine u times v divided by length of u times length of v, or here we can say inverse cosine u times v divided by length of u times length of v. The dot product of two vectors u and v is given by, what we have here is based on this part, which is on left side. So u times v is equal to length of u times length of v multiplied by cosine theta. So based on what we have here, we can also write cosine theta, it is equal to u times v divided by length of u times length of v. Now here in this example, find the angle between these two vectors. U is equal to I minus 2j minus 2k, and v is equal to 6i plus 3j plus 2k. So on this part first, I'm going to find dot product of these two vectors, u and v. So this is equal to 1 times 6 plus -2 times 3 plus -2 times 2. And this is equal to -4. And finding length of u, which is equal to square root of 1 square plus -2 square plus -2 square based on what we have here. And finding length of v, this is equal to square root of what we have for v, it is 6. So here we have 6 square plus 3 square plus 2 square, and this is equal to square root of 49, and that is equal to 7. Now finding what we have for cosine, this is equal to u times v divided by length of u multiplied by length of v. So this is equal to, for u times v, we have -4, and length of u, it is 3, and length of v, it is 7. So -4 divided by 21, this is -0.190476. Now finding theta, this is equal to arc cosine. So here we have this number. And that is approximately equal to this number, 1.76 radians, or 100.98 degrees. Orthogonal vectors definition: vectors u and v are orthogonal if u times v equal to 0. Example: to determine if two vectors are orthogonal, calculate their dot product. Part A. So here we have these two vectors, u and v. For u we have 3, -2, and v we have 4, 6. So here on this part, u times v, it is equal to 3 times 4 plus -2 times 6. So this is equal to 12 minus 12. It is 0. So dot product is equal to 0. That means these two vectors are orthogonal. Now part B, here again we have u, v. So multiply these two vectors. This is equal to 3 times 0 plus -2 times 2 plus 1 times 4, and this is equal to 0. So here again, these two vectors are orthogonal because u times v, it is equal to 0. Part C, 0 is orthogonal to every vector u, since based on what we have here, the product, it is equal to 0. So 0 times u, here we have 0, 0, 0 times u1, u2, u3. So this is equal to 0 times u1 plus 0 times u2 plus 0 times u3. This is equal to 0. Dot product properties and vector projections. Here we have properties of dot product. If u, v, and w are any vectors and c is a scalar, then number 1, u times v is equal to v times u. Number 2, c times u inside parentheses multiplied by this vector v, it is equal to u times inside parentheses c times v, and that is equal to c times inside parentheses we have u times v. And number 3, here we have u times parentheses v plus w, and that is equal to u times v plus u times w. Number 4, u times u, it is equal to length of u squared. And number 5, 0 times u, it is equal to 0. Here on this part we have the vector projection of u onto v. So here is u, and here we have v. The vector projection of u onto v is the vector. This is projection u onto v. That is equal to u times v divided by length of v squared multiplied by this vector v. That is equal to u times v divided by length of v multiplied by this direction v divided by length of v. The scalar component of u in the direction of v is v scalar length of u multiplied by cosine theta. That is equal to u times v divided by length of v, and this is equal to u times what we have for direction. Here is v divided by length of v. Example, find the vector projection of u equal to 6i plus 3j plus 2k onto v equal to I minus 2j minus 2k and the scalar component of u in the direction of v. By the definition, the projection of u onto v is given by u times v over length of v squared times vector v. So first I'm finding dot product of these two vectors. Here we have 6 times 1 is 6, and we have 3 times negative 2 it is negative 6, 2 times negative 2 it is negative 4. So this is equal to negative 4. And here length of v is equal to the square root of 1 squared plus negative 2 squared plus negative 2 squared. So this is equal to the square root of 9, and that is equal to 3. Now use what we have for u times v and this length of v here on this part to find for the projection u onto v. So this is equal to, here on top we have negative 4 divided by length of v is 3, so 3 squared is 9 multiplied by v, and this is equal to components negative 4 over 9. So negative 4 times negative 2, we have also 8 divided by 9, and here we have 8 over 9. Now finding scalar component, it is equal to, based on what we have here, it is u times v divided by length of this vector, and that is equal to u times v. We had negative 4, and length of v from this part it is equal to 3. The vector u is sum of two perpendicular vectors in vector projection u onto v parallel to v, and the vector u minus projection u onto v perpendicular to v. Your example verify that the vector u minus projection u onto v is orthogonal to the projection vector projection u onto v. By definition, projection u onto v is equal to u times v divided by length of v squared multiplied by v. This vector projection u onto v is parallel to v based on what we have here. So it's enough to show that the vector u minus projection of u onto v and vector v are orthogonal. So to show that the two vectors are orthogonal, we need to show that their dot product is equal to 0. So dot product, here we have u minus for projection u onto v. Here we have u times v divided by length of v squared times v, then multiplied by v. So this is equal to, so using dot product, here we have u times v minus, here we have u times v divided by length of v squared multiplied by, here we have v times v So this is equal to U times V minus U times V divided by length of V squared multiplied by, here we have V times V, so that is length of V squared. So this part we can cancel. And this is equal to U times V minus U times V, which is equal to 0. So dot product is equal to 0, and that means U minus projection U onto V, and V are orthogonal. Here we have the definition: the work done by a constant force F acting through a displacement. Here we have D equal to this vector from P to Q, and that is W equal to dot product of F and D. So based on what we have here, the work done by a constant force F during a displacement D is length of F times cosine multiplied by length of D, which is the dot product of F and D. Here example, length of F equal to 4 newtons and length of D equal to 3 meters, and our angle it is equal to 60 degrees. The work done by F in acting from P to Q is, so when we know that vector D it is equal to vector from P to Q, by definition work is equal to force times distance, and this is equal to magnitude of F multiplied by magnitude of D times the cosine of the angle between the two vectors. And now based on what is given for magnitude of F, we have 40 multiply magnitude of D, or distance, this is 3 meters. And here for theta we have 60 degrees. So this is equal to 40 times 3, it is 120 times cosine 60 degree, it is equal to 1/2. And this is equal to 60 joules. Joules are the units of work.